So today we're going to look at finding the probability of an event by using the definition of probability. An experiment is an activity in which results are observed. A trial is what each observation is called. An outcome is the result from a trial. And the sample space is the set of all possible outcomes of an experiment. So here's some examples. So here, when you flip a coin, your sample space would be heads or tails. When you're rolling a number cube, your sample space would be the numbers 1 through 6. And if you're guessing the number of marbles in a jar, your sample space would be the whole numbers. An event is any set of one or more outcomes. The probability of an event, which is written P with the event that you're looking for, is a number from 0 to 1 that tells you how likely the event is to occur. The probability of 0 means that the event is impossible or can never happen. So this would be like flipping a coin and asking what's the likelihood of getting a 6. And the probability of 1 means that an event is certain and it has to happen. Probabilities of all outcomes in the sample space must add up to 1. This chart just kind of gives you an idea. So here's 0, it never happens. 50% or a half, and then always happens. So we are going to give the probability for each outcome based on our spinner. So here, the outcome of 1, there are 3 of them, and there's 8 total, so our probability would be 3/8. For our 2, it would also be 3/8, but then for our 3, it would actually just be 2/8. Now you notice, if we were to add all those up, it would equal 8/8, which is 1. So here, if we roll a number cube, the probability of getting a 1 would be 1 out of 6, 1 out of 6, because each side only has one number on it. So altogether you'd have 6/6 again, which would equal 1. To find the probability of an event, sometimes you're going to have to add the probabilities of all the outcomes that you're looking for in the event. So here's what I mean. So if a quiz contains 5 true or false questions, and you guess randomly on every question, the table below gives the probability of each score. So here's your probability for getting a 0, a 1, a 2, a 3, a 4, and a 5. And we want to know what's the probability of guessing 3 or more. So if you're guessing 3 or more correctly, that means it includes a 3, a 4, and a 5. So we're actually going to add all 3 of those probabilities up. And when we do that, we actually find the probability is 0.5 or 50%. So why don't you pause the video and try this one on your own. Now we're looking at what's the probability of guessing fewer than 2. So here we would only be looking at 0 and 1. So 0.031 plus 0.156. And we find our probability is 0.187, so about 18.7%. Alright, pause the video, try this one out as well. Okay, so here getting a 4 or 5 would be passing the quiz. So we're going to add those up. We find that it's 0.187 or 18.7% again. Now hopefully you notice that the probability of getting a 0 or 1 is this exact same as the probability of actually passing the quiz. Alright, so 6 students are in a race. Ken's probability of winning is 0.2. Lee is twice as likely to win as Ken. Roy is 1/4 as likely to win as Lee. And then Tracy, James, and Kadeem have all the same chance of winning. We want to create a table and show the probabilities for the sample space. So if we have Ken, Lee, Roy, Tracy, James, and Kadeem. I'm going to start with Ken because it actually gives us his probability. It's going to be 0.2. Now here it says Lee is twice as likely to win, so we can double Ken's, which makes his 0.4. Roy is 1/4 as likely to win as Lee, so we would divide that by 4, which is 0.1. Here, since Tracy, James, and Kadeem have all the same chance, that means whatever's left has to be divided among the three of them. So if I do 0.2 plus 0.4 plus 0.1, oops, I get 0.7. So that leaves 1 minus 0.7, or 0.3 left. Well, 0.3 divided by 3 is going to leave each of them with a 1/10 chance of winning the race. So why don't you pause the video and try this last one for yourself. Okay, so here we have Fred, Willa, Betty, and Barry. Okay, so Fred is pretty likely to win. He's 0.6. Willa's is 1/3 of Fred's, so if you do 6 divided by 3, you're going to get 0.2. Those two together give us 0.8, which leaves 0.2 between Betty and Barry, and since they are equally likely, each of them, again, is 0.1.